Bismillah ar-Rahman ar-Rahim. This is CS 310 Data Structure lecture number 10 for Q. Revision for recap for Q. Already we started for Q's different stack for storage, just as this Q's first in, first out. So already we finished as the Q implementation by using the array and the Q implementation by using a linked list. And so already we have finished all algorithms for arrays and linked list. Today, inshallah, we're going through LQ priority queue. So the objectives of this lecture: analyze and define memory requirement for Q data structure. This is the same for the previous two lectures. Just here where discover some Q priorities and how to implement. Priority queue recommended chapter 9. So priority queue is a queue where each element has a priority. All queue before data structures, there is no priority. Only one value stored for each element. But here we need to store another value. This value is the key or priority. So priority or key should be stored for each element. So an element with high priority is served before an element with low priority. So priority should be integer or k. For example, 0 priority, 1 priority, 2, 3, 4, 5, 6, and so on for it. If we have 3 elements, 3 K3 that has K3 and K4 and K5, the highest priority at 5. So at 5, element at 5 should serve firstly, or the first one will serve. This is next for it. So this is a special case of a queue. A queue meaning that first in, first out. But in priority queue, it's not first in, first out. Just where you will serve the highest priority. Right? The high priority is served before an element with low priority. So we have two ways to keep the priority queue. The first way, unsorted list. The second way, for sorted list. For unsorted list, meaning that we will insert one element to the list, but we'll take one operation. Any questions? Any questions? Yeah? Anybody have questions? شباب حد عنده سؤال؟ If you haven't any question, please silent. Focus with me. Right? Right. For unsorted list, we will take one operation for NQ. We can insert the item at the rear end. But for DQ, we will take n operations since we must traverse the entire queue of length. Right? So what is the difference between one operation and the n operation? This is unsorted. So we will add to the list without any sort. This is unsorted. But to remove from list should be defined the highest priority element to remove. So we'll traverse all elements in list and then choose the highest priority to serve or to remove. Second one, for implementation with sorted list like this is sorted list. Sorted list will insert take n operation. So it's the opposite of the first one. So the will insert by n operations, meaning that we need to find the place where to insert the item. We need to find the place where to insert the item. So we need to traverse all elements in a queue before add element. Okay? Because we need to, all elements should be sorted. From start at the first, from the low to high. Why? Because when we will remove these elements from list, will remove direct without any traverse. How we will remove from the front? We will remove the highest priority. So the unsorted list we use only one operation to add. To NQ, one operation. To DQ, we need n operation, but for sorted list, we need n operation to insert, we need n operation to NQ, but we need one operation only to remove, right? Okay. Next, for priorities, each element in the priority queue is modeled as key value. So we will store key attached with the value, right? If we see, everybody can see here sequence of priority queue examples. This is calling for NQ5 and A. 5 as a key for value. A is the element, data element, but 5 is the key. So what is the output and what is the NQ result for sorted list and for unsorted list? This example is very important because we will take this as the NQ5 and A. 5 and A, this is the first element added to the list. So there is no difference between sorted and unsorted to add the first element. It's the same. But for the second element, 9C, this is a higher priority, higher than 5. So this is well for sorted list. Take only one operation. So we'll add to the rear. Back to again for sorted, for insert, take n operation. Right, very good. So to add 9 for insert, for sorted list, we need to traverse all element to see the place of 9. And 9 is greater than 5, so we need a when insert, inserted, and sorted. Should be keep all elements sorted for sorted list. But for unsorted, that's okay. We can add at the rear direct without any sort. No need to traverse. But when DQ from this element, we will traverse to find the highest priority to DQ. Again, to NQ3, K for value 3 and value element by B. This is well to add for sorted list. We need to traverse all elements and keep this location or place for 3 here behind 5. So this is list should be sorted. This is the 9, meaning that's the highest priority. This is the next highest priority, and this is the last one, the lowest priority for 3. But for unsorted list, we'll add direct at a rear. To DQ, meaning that we'll DQ direct from sorted list from the front. So remove the 9C. And to traverse, we need to traverse. So we cannot DQ 9 element without any traverse because this is unsorted list. We need to traverse to find where is the highest priority element. So remove this element. For NQ70, 70 for sorted list, coming up next to 5. So, but for unsorted list, behind the back 3B. This is for NQ70, but to DQ, meaning that will remove the highest value for the highest K for this list. So, what is the highest K? The 7, so remove 7 directly from sorted list, but here for should be traverse. My question here, for a traverse to remove, a traverse started from front or from rear? Who can answer these questions?
It's all, Doctor.
For unsorted.
Yes.
For unsorted. To DQ from unsorted, we need to traverse. So traverse for unsorted list started from front or from rear?
Always from front.
Started from front.
Yes, from front.
So we cannot start traverse from rear.
على حسب اللي نستخدمه.
على حسب. ايه هو حسب ده بقى؟
يعني ستاك أي نوع، أقصد لينك ليست، أي نوع من اللينك ليست.
لا هو
linked
يعتمد على
list,
احنا كيف
okay.
ماشيين دكتور.
We can start it from rear or should be started from front. We can, okay.
Yes, we can.
From both.
Yes, we can.
From both.
From
Very
rear.
good. From both, we can from both. Very good. Yasser, Abdullah, Qahtani, good. Ala, good. Okay, we can start it from front. It's similar, yeah, no problem for the traverse. This is traverse, okay. Also, the special case for queue, priority queue. Okay, so for DQ from sorted list. For DQ from sorted list, we DQ remove from the front or from the rear?
Rear.
For DQ?
ايه.
Sure?
DQ, yes. We
من الفرونت.
from last.
لا دي كيو يجي من قدام.
لا من
اللي
الفرونت.
بيتكلم وبيقول from
فرونت دكتور.
rear.
الهايست بريورتي.
عايز اعرفه بس. From front. Why from front? Already this is sorted, right? This is sorted. So we'll remove from front, right? Type.
Yes.
For sorted list, to NQ in sorted list, we will NQ at rear or front. Who can answer?
At rear.
دكتور.
At rear. Very good. Who agree for this answer? Everybody agree? طب مين مش موافق؟ Who disagree?
الدكتور مو قلنا الكيوينج اللي يبدا من قدام البرايورتي تيجي من الفرونت حق
for sorted list. Yes, for priority, highest priority from the front. Good. For TQ. For NQ, my questions again. For NQ, for sorted list NQ. When can we NQ? At front or at rear?
رير.
على حسب البريورتي دكتور.
هو سبيشال هو سي مين اللي بيتكلم؟
ممكن الاثنين.
ممكن الاثنين؟
ايه على حسب البريورتي. اذا
لا
كان
دكتور الدي كيو يكون من الرير والان كيو يكون من
علاء
الفرونت.
depend on priority. You can chat. That's okay. Very good, علاء. Why? Because this is the key priority. Okay? This is the key priority. We cannot direct NQ to the rear. Right? This is sorted list. We cannot NQ direct to the rear. لو احنا عملنا NQ direct للرير يبقى مش هتبقى sorted list صح؟ try for 9 لو حطينا 9 direct خلاص يبقى ال 5 وبعدين 9 ما يصير. طب 3 لو حطينا direct يعني this is special يعني قدرا يعني لكن ما يصير. لازم انا بدور traverse. We need to traverse for sorted list. We need to traverse. A traverse for the appropriate place for the key. صح ولا لا؟ So this is based on or depend on the priority. Okay شباب؟ Right? Clear?
Yes.
كلير.
طيب. For DQ here DQ7 DQ from the front for sorted list. But for unsorted, we cannot DQ from the front. We will DQ the highest priority. So for any operation, even if it's sort for NQ or DQ or NQ for unsorted, this is should be for DQ and unsorted, meaning that we need to remove the appropriate. We need to remove the highest priority. So we need to traverse. If we need to traverse, we cannot go direct for any rear or front. Okay, this is this slide that's for NQ and DQ. A priority queue operations, we have set of method for operations, get max. Get max that return but does not remove. Return the highest priority or the maximum key. Return null if the priority queue is empty. DQ that will removes and return an entry key value having a maximum key. It's also return null if the priority queue is empty. To enqueue or to insert, create an entry and insert it in the correct order, right? For entries are sorted by key. If it's sorted, traverse to insert at appropriate place or to create order. Correct order. It's empty, that will return true if the priority queue is empty. Return false if it's not empty. Size to return the number of entries in the priority queue. Priority queue implementation using a linked list or sorted list. So we'll choose only sorted list from the priority queue for using linked list and sorted linked list. We have sorted and unsorted list for this course. So sorted list may be implemented by array or may be implemented by linked list. We'll choose only using a linked list for priority queue and choose only a sorted list. Okay, right. This is the using a linear linked list for priority queue to insert or enqueue. Enqueue is given key and value. Given key and value for single linked list. This is input. Our output to insert operation or insert in the correct order. So this is the first one to create a new object or a new node of the priority queue linked list. So and initialize current and the previous. Current by the front or head in the linked list and previous for null for the what is the previous for the current or what is the previous of the head? The previous of the head equal null in linear linked list or single linked list, right? Just we need to repeat to traverse to find the correct order. So check for while current not equal null and the k less than current dot k to locate the correct position or correct place. Just by one by one for each repetition. If it's not this condition, not means this is not equal null and the k still less than the current k. So move to next linked list. Move to next by current equal current dot next and update the previous by the current node. After finish from this repetition, we'll finish in two cases. The first one, if this current not equal null and the k equal less than current k, that's okay. To current not equal null, but k less than current k, that's okay. We'll exit. Sorry, if k greater than current k, so we'll exit at the appropriate place or the correct position, right? But if this is finished by current equal null, that meaning we haven't any value, we haven't any element for this. So this is the previous equal null, meaning that then front equal new node, else previous dot next, this is the new case for previous dot next equal new node. So we will put a new node dot next by current. This is like this to add or to insert a node in between for linked list. To insert or to add node in between, we'll check for the order or the order or index of the node. We need k here for the node, the index of the node. This is like this. So we'll try to traverse to find the appropriate place by k less than current dot k, and then add this by what the previous dot next. Add a new node next to previous and before the current. Again, add a new node next to previous and before the current, in between current and the previous. A new node will add it between previous and the current. Okay? So we'll increment the size by 1 because we will insert a new element to the linked list. To remove from the sorted list, direct will remove from the front. So, but first we'll check queues underflow node by is empty. So set node, if it's not empty, just we need to keep the current front by temp variable, then update the front by front.next, and we'll decrement the size by 1. Finally, we'll return all the front or our values that's highest priority and priority queue. Next, to find get max. Get max similar to DQ, but without remove. Just return the value. If get max meaning that if it's empty, queue is underflow, otherwise we'll return the front. So get max for linear linked list to return the front. It's empty, meaning that check for size. If a size equals 0, this is empty, otherwise this is not empty. So we'll return a true if a size equals 0. For implementation using Java for priority queue, we need to check for some elements should be, variable should be. For example, front, this is null initially. Also size for number of elements in the queue. Also, where is the rear here? We need the rear, huh? Where is the rear? We need the rear, huh? Question, my question. Can answer? Anybody can answer?
Sorted, لا.
Huh? We need the rear to store a rear for linked list for a queue, priority queue class. We have to store a rear. No question, no answer? No, good, no. Say, why not? Why? For sorted, no need, huh? For sorted, no need. Because for NQ, we traverse. We can traverse from front. Very good. We can traverse from the front, right? For DQ, we will DQ from the front. So we no need for a rear. Very good. So just only front equal null, size equal 0, and then we'll use just to remove or DQ, insert and display. So back to the structure of a node is different because we should take care for the arguments here or given a value or element will store also next, but we need to store key, that's the priority key. Also this is to string, everybody know, for display values, just we can format any member or any values for this object. The next for max and remove. Max is that will return a front value. For to remove, just will remove from the front. Back for DQs, not here. This is good. The next for this is the insert. To insert is similar. This is implementation for NQ for priority queue or insert given key and value. So it's the same algorithm, but just is by Java. Just here create a new object from node and then given value and key. So we can store the current by front and keep previous by null and check. This is the same checking algorithm for while the current not equal null and the new node.k less than current.k. Update the previous equal current and move to the next by current equal current.next. So if the previous equal null, meaning that this is only at beginning of list or front equal new. So when as this is the first element added at the front, otherwise we'll add previous.next equal new node, and for all add the new.next equal current. Increment the size plus plus. If this is the last one, current equal null, so we can update. This is the last node added for the linked list. And increment the size by 1. Okay, this is for insert. Next for application. This is application for a priority queue. Just I want to ask a question for what is the order for this started from left side to right side. The highest priority will stored at left and the lowest priority will be stored at right. So who can write the after insert 10, 15, 9, 2, 3, 5, 1? Who can just store all elements? Just who can write this element order? Can you share with me chat for? Just write in chatting what is the order for all elements after to display. What is the output of display? Priority queue.display. Who can answer? Who can answer? Yani you can write this is like this. This is AA. Very good. Who answer? Zafir. Good. AA, BB, CC. This is order. Okay. Another one. Faris. BB, AA. Very good. Very good. Faris. Good. Good. Yani write only one chatting. Please, don't write for each one. Don't write element and enter. Only yes, Ziad. BB, very good. AACC, last. Very good, Ziad. Ziad, okay. Faris, okay. Ala, okay. Very good. Muhammad Adnan, okay. Very good. CC, FFEEDDGG, last one, GG. Very good. I think everybody know how to store, how to insert. Why? Because this is sorted list, right? Sorted list meaning that we need to traverse to set or to insert the highest priority as the appropriate location, right? Very good. So this is the right order for BB, AA, CC, FFEE by this order, because order by 15 and next 10, next 9, 5, 3, 2, 1. This is the started from the left, the highest priority at the left, the most left, highest priority 15, and at the most right, lowest priority at 1, which equal element equal GG. Okay, so after display, we'll display by this order. So what is the output of BQ.max has a max priority? It's BB, very good. So what is output to remove? What is the element we'll remove? Remove max, we'll remove BB. If we display after remove max, we'll display from AA up to GG. So if we display again a max, so max will return AA. To remove another max, we'll remove AA. And if we display here, the last display will display from CC to GG, right? From CC at 9 priority to GG at 1 priority. So this is the output of order for the first one, BB to GG for by this order, BB, AA, CC, FF, E dot DDGG, and so on. For BB has the max priority, K equal 15 value, BB is deleted for DQ, and so on, display again from AA to GG, and the maximum priority here, AA, and so on. For if we remove or DQ AA, this will display from 9 from CC to GG, and so on. This is the priority for sorted. Applications of queues. Very good. Okay. Just we need to take just 10 minutes break and back for applications queue. But I want to stop. But for applications of queues, one of applications, direct applications, we can use direct applications to use the queue to serve at anything for medical centers, for different business, and so on. For this is direct applications. Serving request of a single shared resource for printer, disk, CPU for operating system, will manage the spooling, will manage serving for printer, also disk or CPU and so on for a queue as a buffer, because the queue is first in, first out, and so on. Call center phone system use a queue to hold people in line until service representative is free. Also, operating system will maintain a queue of jobs that are ready to execute or waiting for input-output operations. Indirect applications for auxiliary data structure for algorithms, also for component of other data structure, we can use it indirect. We'll use some of applications therefore on a queue. The first, one of the application round-robin schedulers. This is type of service for, consider, we will assume as a buffer we have for 6 elements like this, 6 elements or 6 services. For this is for each block, yellow block here is service. So if we have a schedule of services just inserted for the queue, so we have algorithm. This is for round robin, this is recycle cycles for a circular service. Started for DQ the first from the front, serve this services or call this service or share this service, and again if after finish insert or in queue again to the queue. In queue meaning that in queue at the rear, also one by one. So forever we have, this is the maximum number of services in this queue, and repetition for each one, DQ and NQ, DQ, the same services. So this is implementation for round robin scheduler using a queue by repeatedly performing these steps for queue service element E, and then NQ again this service to the buffer. A practice from the book, we have set of practices. The first practice for, suppose you have double-ended queue D containing a number of 1, 2, 3, 4, 5, 6, 7, 8 in this order. Suppose parser that you have an initially empty queue, give a code fragment that uses only D and the Q and no other variables, and result in D storing the elements in the order by this order 876. By meaning you have double-ended Q for D and you have another Q, and just by using D and the Q only D and the Q only, how to reverse the elements in the double-ended Q D to become reversed. This is started to, suppose you have 1, 2, 3 to 8, but we need to display or print a Q by D7, 876 and so on. Result, it should be in D, storing the element in the order, in D, in the same D double-ended Q. So our problem here to reverse all element in D, reverse it and store in D, not reverse and store in another Q. But you have, you can use only another one Q to have to reverse. This is the problem. Everybody can suggest or answer for. Anybody can suggest idea for this? Who can answer? Just say an algorithm or how to, by using what? Nobody can answer? Round robin, we can use round robin. Take care for, we have only a double-ended Q and another Q. So you have two resources. The first one that's include or hold all elements. Second one just for help. Okay, but we need the result in the same double-ended QD again. No, not round robin. Any idea? Any idea? Nobody have answer? Should we use normal queue or the priority queue? Up to you. You have double-ended queues. So the only questions is not applicable here because we have elements, it's not priorities. And just 1, 2, 3, 4. Where is the priority? There is no priority here, right? Just here we have double-ended queue and another queue. There is no priority. Okay. Let us to see. So nobody have answered. So let us to move for to answer 6.11 and back. This is 6.11 description. The requirement only D and the Q and no other variables. To contents of D should be in reversed order 876. This is the requirement. So we have double-ended Q, NQ and DQ. You can NQ at front. You can DQ from the front. For double-ended Q, you can NQ at rear. You can DQ from rear. So by using a Q, you can DQ elements from D and NQ them into Q. So we can DQ front or DQ rear. This is a question who can answer? For this, we can DQ front or DQ rear. This question. Another question, if we DQ elements from Q and back again for NQ to D, this is the idea. But NDQ front or NQ at the rear. Everybody can try it. If we DQ from front here, 1, and NQ at front here will add 1 at 1. And next for 2, 1, 2. So the result is 1, 2, 3, the same. So, but for DQ from this element and NQ again, will add as the same. But what is the new for this? So we need to answer for this two questions. Is very important. Nobody have any answer for these questions? Boss, Ghazi, boss. Another one? If you try it, just to try this problem is very easy. So just we need to this Q here for swap just with temporary buffer just to reverse. You can use NQ from a front, right? And then Q at front and so on. Back DQ from Q and then add to a DQ at rear. So this is also for if you are using a DQ from a rear, you have to NQ at a rear again for this, right? So this is will add for this Q only for DQ at NQ at a rear and DQ from the front. So this is a 1, 2, 3, 4, 5, 6, 7, 8. You will DQ rear from the front. From DQ rear for double-ended Q, 8, and then NQ will NQ here, 8, 7, 6. But NQ here, meaning that it's not NQ at the front, but NQ at a rear. But this is will add to rear because this is the first set. Added 8 here, not the front here, but it's become front at the last element because this is will move to. This is the conceptual, right? So next to remove from this Q and NQ for this, also we will remove from the front and DQ, right? Sorry, NQ at the rear. If we NQ at the rear, this will become at the front after a NQ1. So this is the last one NQ, this one, and 8 is the first one NQ, right? Clear يا شباب? Slide clear, question problem clear. You can use clear, good. You can use this is for DQ from front, but should be NQ at the front again here. Also, you will getting the same order. Clear? Everybody? خلاص? Okay. Should be in the same, but this is the standard Q, single Q, not double-ended Q. Back to this is the algorithm for reverse D using a Q. But take care here should be understand the problem. We need our result in D, not in Q. Okay, our result should be in D. In Q is very easy to DQ from rear. And NQ at the rear, that's okay for Q, but our result should be in D, right? This is the algorithm or solution for this problem, just for input given D, output refers D should be by this. The method for each element Q, 8 element, while D is not empty, NQ, and DQ from rear. Another loop for while Q is not empty, DQ from Q and NQ rear at D. Take care for DQ should be return value for any implementation for DQ, like Bob and stack. Back to our next questions for 6.12. Repeat the previous problem using DQD and an initially empty stack. We can use stacks. Another idea for using the stack to reverse the same sequence of numbers. We can use the stack. This application given is empty stack S and D. So requirement only D and S and no other variables. Take care for no other variables. I know not everybody can answer this question. All right. Temp X, temp Y, there is not right, should be take care for your constraints. You have constraints here, no other variables. So we'll start for contents of D should be reversed by DQ, right? Or DQ from rear or from front. and the stack is no, only one push, خلاص, push or bob. So we can use DQ rear or NQ rear. Who can answer? Nobody have answer for this equation? Nobody here? Nobody can answer for this equation? We have two questions. To repairs by using the stack, to repairing this sequence, we'll use DQ front or use DQ rear from D. Also for bob elements from stack and back to NQ and D. Will NQ rear or NQ front? Somebody write DQ front, bob NQ rear.
دكتور.
Yes.
يعني أول شيء نسوي دي كيو رير زين
أيوه.
وبعدين ندخله في الستاك أو لا نسوي عفوا الدي كيو فرونت عشان الواحد يروح آخر شيء ونطلعهم كذا يعني الواحد يكون في البداية وبعدين الاثنين وبعدين الثلاثة لين الثمانية بعدين نسوي له بوش وندخله من الفرونت.
تبوش وتدخل في الفرونت. بس انت لو عملت بوش ودخلته في الفرونت ايه اللي هيحصل؟ هيطلع نفس السيكونس.
او لا ندخل عفوا في الرير الاند كيو رير.
ماشي اوكي. good محمد اوكي. So ال NQ last NQ maybe in a rear. So you will use a DQ based on the first NQ. Okay. You will use NQ based on the first DQ. If you use the DQ from front, you will, because this is one, will be the first element added. This is well the last element. So the last element added, we need to reverse. We need to the last one added. Sorry, to push the stack is 8. So we need to put the first one will NQ at the front. Okay. Right. Let us to see for this. So we'll use DQ from front. This is the last one. This is the first one pushed, and the last one pushed is 8. So when we bob, this is will bob start from 8. This is by force because this stack we cannot bob from anywhere. This is only bob the start from 8 to 1. The first one bob 8. So we have 8. And we need to NQ for this D. And we need to add, this is the maximum at the most left. So we will NQ at the rear. Okay. This is the answer for or idea of answer, just DQ from the front, push to stack, and the result will bob again and NQ to the rear. Okay, Shabab, clear? Right? Clear يا شباب؟ طيب what is the algorithm for this? Just for algorithm for stack, prepare a stack, and just while D is not empty, push DQ front and push to stack. Another loop for while stack is not empty, bob all elements from stack one by one, and NQ to at the rear for D. Back to last equations for law of Braggs. 6.24 implement the method using signature concatenate linked Q2 for the linked Q class that takes all elements of Q2 and appends them to the end of the original Q. So we need to concatenate just to link it. This is solution direct for let original Q1, 1, 2, 3, 4, 5, 6, 7, 8. And already we have algorithm for concatenate Q1 and Q2. Given Q2 by 9, 10, 11, 12, our output should be 1, 2, 3, 4, 5, 6, 7, 8, as this is the old, and the next for 9, 10, 11, 12. 9, 10, 11, 12. This is concatenation for between Q1 and Q2, but all elements in Q1, the original, okay? So how to use this, how to concatenate? Just while Q2 is not empty, right? So read one by one for NQ at Q1 at the end, right? DQ from Q2 and NQ. So NQ at the end, this is standard, not priority AQ. Right? So we have to NQ at the rear. Okay? This is well NQ at the rear. This is the end of priority queue. So we can start for the next, or I can answer for any questions. If you have any question, can answer for queue. يا شباب اللي عنده سؤال في الكيو، اللي عنده سؤال في الكيو. Do you have any questions? Clear?
دكتور لو
دكتور،
ترجع
ما قصرت.
تروح دكتور لو تروح آخر سؤال إجابة الجوريثم.
آخر سؤال في البريوريتي هنا.
الجوريثم أيوه نعم.
Yes. ده 1.
ايوه الكيو 1 تسوي ان كيو للكيو 2 دوت دي كيو، يعني يعني يسحب من الكيو 2 اخر element ويضيفه على الكيو 1 صح؟
يس. يسحب منين؟
الكيو 2.
يسحب منين من الكيو 2؟ من الفرونت ولا من
اللي هو 12.
لا
اسف 9.
لانه بيسحب من الفرونت صح؟
اي نعم.
ليه؟ لانه ده ستاندرد كيو ما هوش بريوريتي. حتى لو كان
Yes.
بريوريتي كان هيسحب من الفرونت، ما كان هيبقى الترتيب مختلف صح؟
نعم ويضيفها في الكيو 1 صح؟
ان كيو في الكيو 1، بس ان كيو فين؟ في الرير ولا في الفرونت؟
في الرير طبعا لانه
خلاص يبقى على طول هيأدي افتر 8 صح؟
تمام.
next to 8 next to 9 and so on for A 1 by 1 صح؟
Yes.
Clear?
Thank you.
Welcome. Any question? Any question يا شباب؟